Welcome to Mrs. Sou's Math World. Today we're going to discuss the second derivative of a function. Please go to page 4.9 of the booklet. Okay, so it's actually about after you differentiate it once and you differentiate the first derivative. So let's use the notation for this one. Okay, this is by the mathematician called Navis. Okay, so when you have a function, you get the first derivative, that means you differentiate it once. For the second derivative, that means you are going to differentiate dy dx with respect to x again. And then that means this is the derivative of this function. Okay, so after you differentiate it, we will call it as d square y dx square. That means this is the notation of the second derivative. Alright? So please put it in the table. And then for the rest of them, they are of different sorts of notation. Okay, so this is by the British Newton. So this is by the French Lebis. Okay, so here are the notations. So this y prime prime, if I differentiate it twice, or you call double prime. Okay, so the Newton one is usually used for physics. Because Newton discovered the derivative, it's basically used for physics. Okay, but for the base is used for mathematics. Okay, so this is the short form y prime prime and f prime prime also. So the calculation is similar as usual. For the first derivative, so it's like this, and then simplify. So and you will get this one as the first derivative. So let's move on to the second derivative. So we write down d square y dx square. Then actually we do this as the same way. The way same as before. Negative 16 times 3x squared plus 5 over 2 times 2x and plus 3. Okay, you will get negative 48 x squared plus 5x plus 3. The calculation actually not difficult for you, right? But I want to discuss the meaning of it. Can you see the original function? The highest power is x to the power 4. After you differentiate it once, the highest power goes to power 3. And then if you get the other derivative, that means you d it again, you will get x squared. So what happens next? If I differentiate again, what will we get? Anything interesting? How about if I differentiate it for many times? If I differentiate it for 10 times? Can you guess what we get? When we differentiate once more, you will get negative 96x plus 5 becomes power 1. Differentiate even once more, you only get negative 96. Already a constant function. So after that, I differentiate once more, and you will get 0. Okay, so what does it mean? If I have 0, that means we have nothing to differentiate. Then if a power even higher than it, or can I say power, maybe the times, right? Then it will becomes 0. Right? So it is actually very interesting. For derivative, you can differentiate it for many times. So this is basically the concept. So this one looks like a routine calculation, right? But it is a little bit interesting compared to the last one. Anyway, let's start. So we start from the first derivative by using product rule. So for e to the power something, it is quite good to use a bracket to show that it is the product rule. Okay, and then what should we do next? So there are two options. Option 1, differentiate using product rule like this. That means we differentiate these two, and then you will get differentiate 4x minus 5 e to the power 3x, and then plus 4x minus 5, and then do it in this format for 2 times. That means you will get such a big thing. See? 1 big thing, 2 big objects, 3 big objects. This is 3, this is 9, this is the 4th one. And then you need to expand inside, expand inside, expand inside. Wow, for many times. So this is not a good method. So clearly, we should simplify it first. But be careful, when we simplify it, we need to multiply 3 to 2x squared minus 5x plus 1. So you will get 6x squared minus 15x and plus 3. So calculate it first. And then, so we can handle for x squared, 6x squared. For x, you have 4 minus 15 minus 11x. Okay, so constant negative 2. So basically, it is step 1. So after we simplified it, then we can differentiate it again. And you see the difficulty is similar as the first one, okay? Means 12x minus 11. And then it be back like this, okay? And then 3 times e to the power 3x. So we do the same thing as the upper part, which is multiply the 3 inside. So having the second line, and then lastly, we combine them together. And we can get the last one to be the final answer. So this question is actually more interesting, right? Because after we simplify it, we still get the same thing, isn't it? I mean, the e to the power 3x is still here. So that's why after you differentiate for 2 times, we still get the x squared here. Maybe you can think about why we can get this. Let's move on to the next video to look at example 4.19.